Well, if there is some rebound, water hits and it goes up. You know, it splashes, right? So you get some rebound. Does that add to the force or take away from the force on the roof?
It would add to it
Why?
because the change in velocity will be greater.
Yes, exactly. The magnitude of the change in velocity. Okay? So some of the water, maybe 1% of the water, rebounds at maybe a meter per second. Okay? And it might be more than 1%. It might be a few percent, but it's not a very high percent. Okay? Now, that means that it changes velocity, the magnitude of the velocity change. Well, you've gone from negative 8 meters per second to 1 meter per second. That's a negative 9 meter per second change, right? I'm sorry, you've gone from 8 meters per second to negative 1, which is a negative 9 meter per second change. So 1% of your water changes by ballpark 10% more, okay? Now that's not going to be a big deal. 1% of 10% is a tenth of a percent. So you'd have a tenth of a percent more force due to the rebound. The rebound is important because of the related idea that I mentioned. Gas pressure. Now this is more complicated, but the fundamental idea is simply that you have particles of gas, molecules and atoms, bouncing off the walls of a container. If they move a little faster, they bounce a little harder, okay? And those collisions are totally elastic for the velocity perpendicular to the container walls reverses, okay? On the average. You know, molecules hitting molecules can scatter in all kinds of directions, but on the average, if this is a container wall and you have a molecule that hits here and bounces off here, it's not going to lose any kinetic energy. It's a perfectly elastic collision, okay? It'll transfer energy to the walls, and again, you look at the change in the velocity, multiply that by the mass, and you get the force exerted by a single particle, figure out how many particles there are, and it's a little more complex than that, and we're going to do that in the winter, okay? So it's worth remembering this model, which is one reason I chose it today, okay? So to kind of keep this one in your mind, because it'll make things easier for you later when we do it in a somewhat more complicated situation, okay?